Okay, suppose we have two complex numbers in trigonometric form. So we know their r and their theta, their modulus and their argument. If we want to multiply them together in that trigonometric form, we just multiply the r's and add the thetas. So then we get the product in trigonometric form as the two r's multiplied together times the cosine plus I times the sine of the thetas added together. And to divide, you would divide the r's and subtract the thetas. So for example, to multiply 10 times cosine pi over 3 plus I sine pi over 3 times 4 times cosine 2 pi over 3 plus I sine 2 pi over 3, we would multiply the 10 times 4 to get 40, and we would add the pi over 3 plus 2 pi over 3 to get 3 pi over 3, or just pi. So the result is 40 times cosine pi plus I sine pi. Which is just negative 40 if you write it in standard form. And let's divide 12 times the cosine of 3.9 plus I times the sine of 3.9 divided by the complex number in trigonometric form 2 times the cosine of 2.2 plus I times the sine of 2.2. Remember, to divide, we divide the r's and we subtract the thetas. So 12 divided by 2 is 6. 3.9 minus 2.2 is 1.7. And we get 6 times the cosine of 1.7 plus I times the sine of 1.7. Now, I'll just mention that because multiplication involves adding the angles and division involves subtracting them, you can interpret multiplication geometrically in terms of rotations. That's all I'm going to say about that really in this video. I'm not going to hold you responsible for knowing about that, but it is one reason that complex numbers are used, to give you a way of handling rotations. And I will provide a link or two to other websites that go into more detail about that in case you're interested. So we talked about multiplying, we talked about dividing. What if you have a complex number and you want to raise it to a power? Well, and this has a name, it's called de Moivre's theorem. If you have a complex number in trigonometric form and you raise it to a power, and here we're assuming the power is a positive integer, but really this is going to carry over to any power, positive, negative, fractional, whatever. It's just that if it's a positive integer, then you can think of it in terms of multiplying that many copies of that number together, and you can rewrite it in terms of multiplication and prove that this works that way. So this is true when n is a positive integer, and it still sort of works for other n's. So it just says when you're raising a complex number in trigonometric form to the nth power, raise the argument r, the modulus r to the nth power, and multiply the angle theta by the number n. So for example, what's 2 times cosine 11 degrees plus I sine 11 degrees to the third power? And of course, you could set it up just as multiplication. What's this number times itself times itself? Either way, you have 2 to the third power, and then the angle 11 degrees gets multiplied times 3. So we end up with 8 times the cosine of 30 degrees plus I times the sine of 33 degrees. Another example, what is 2 minus 5i to the third power? Now, if we were doing this without de Moivre's theorem, we would have to write it as 2 minus 5i times 2 minus 5i times 2 minus 5i. We can multiply that all out using the distributive property and the fact that I squared is -1 and all that, and work out what we get. We could do it on the graphing calculator. Hey, calculator, what is 2 minus 5i raised to the third power? And the calculator tells me it's -142 plus 65i. But now let's do it with de Moivre's theorem. First, we would have to convert this to the trigonometric form with the r and the theta. So r is the square root of 2 squared plus -5 squared. It's the square root of 29. And theta is approximately 291.8 degrees. So in trigonometric form, it's the square root of 29 times the cosine I sine of 291.8 degrees. Then when we raise that to the third power, the square root of 29 gets cubed, and the 291.8 degrees gets multiplied by 3. And when you multiply it by 3, you get 875.4 degrees. But if we want something between 0 and 360, we can get the equivalent of 875.4 degrees by subtracting 360 degrees and then subtracting 360 degrees again, and in getting down to 155.4 degrees. So there's the number of degrees between 0 and 360. So we're looking at the square root of 29 cubed, or approximately 156.17, times the cosine of 155.4 degrees plus I times the sine of 155.4 degrees. And if we convert that back into standard form, just work out, okay, what is 156.17 times the cosine of 155.4 degrees? It's about -142. And what is 156.17 times the sine of 155.4 degrees? It's about 65. So in standard form, that is -142 plus 65i. That's what the calculator said. So yeah, that is what we get when we start with 2 minus 5i and we raise it to the third power. Okay, one last example. What are the two square roots of 9 times the cosine of 180 degrees plus I times the sine of 180 degrees? And notice that that's just -9. The cosine of 180 is -1. The sine of 180 degrees is 0. So this is 9 times -1 plus I times 0. So really, I'm asking for the two square roots of -9. If you took the square root of -9, you would get 3i, but there are two possible square roots, the positive and negative square root of -9. So the answer should be plus and minus 3i. But what if we use that formula we were looking at and think of, okay, taking the square root means taking it to the 1/2 power. So what happens if we take 9 to the 1/2 power and we multiply the angle 180 degrees times 1/2? Well, 9 to the 1/2 power is 3. 1/2 of 180 degrees is 90 degrees. So we end up with 3 times the cosine of 90 degrees, which is 0, plus I times the sine of 90 degrees, which is 1. So 3 times 0 plus I times 1, that's 3i. Okay, makes sense. But what about the -3i? Well, we could have just said we could take the plus or minus square root of the 9 here and get plus or minus 3. But another way to look at it is that the angle we put in, 180 degrees, is equivalent to the angle we get if we just add 360 to that and write it as 540 degrees. So if we take 9 times the cosine of 540 degrees plus I times the sine of 540 degrees, and raise it to the 1/2 power by taking 9 to the 1/2 and multiplying the angle 540 degrees times 1/2. We get 3 times cosine of 270 degrees plus I times sine of 270 degrees. The cosine of 270 is 0, and the sine of 270 degrees is -1, so we get 3 times 0 plus I times -1. That's -3i. So that gave us both of the square roots of -9.